Good morning, everyone. Another trip to China. This is my travel number 4. I'm flying today from Brussels, and since most of European carriers canceled their winter flights in 2024, I'm going to fly directly to Beijing with Hunan Airlines, and from there I will take a flight to Chengdu. So stay tuned. I will have a lot of things to do this little short trip of 9 days in China, and I will take you with me to show you what I'm going to do. See you later. So I've just finished my check-in. This trip will be different from other trips because I'm going simply to try to contact some industrial companies. As you know, I'm working with phase change materials with Southwest Jiaotong University. And this time we're trying to integrate some aspects related to the construction and how to integrate the PCMs in building materials. So stay tuned. I will check in later with you and enjoy the trip. Ni hao, everyone. I arrived at China. The trip was long, flying over Beijing, but it went well. And I was lucky I did not need to apply for a visa. So since you stay shorter than 2 weeks with a Belgian passport, you don't need to have a visa. For sure, this is my first trip to Chengdu, and I'm very excited because it feels a bit like from one side coming home because I know many things now. But in the same time, it's a good opportunity to reconnect, to collaborate, deepen the collaboration, and for sure I'm excited to go further with the research and innovation we're working on. This trip is really about a lot of visits and also working on a higher level of phase change material application in buildings. So at the Southwest Jiaotong University, I'm going to meet my collaborating professor, Professor Jinping Yuan, and Professor Zhaoli Zhang and Dr. Nan Zhang. They are the main collaborator. And we are going also to meet their PhD students. We will share ideas, explore some future endeavors of research, and definitely I'm trying to enjoy the city and have delicious dinners and so on. Plus, I'm catching up with Amr Farouk, my alma mater friend, who is now living in Nanjing. He's been living in China for 11 years, so it's very nice to catch up and keep exploring what he's doing. He's also doing groundbreaking work with his PhD, so I'm looking forward. But wait, there is more. I'm also going to visit a cutting-edge company, the China Construction Company, and its R&D center. I will be exploring 3 advanced technologies that they are working with and exploring, and they're already starting rolling them out, so this will be very exciting. And also I would like to share with you that I started my learning Mandarin, so I will take you in a little trip to check a library where I'm looking to have some study material, and I will explore with you the HSK content. So there is much to experience and to share with you. Ready to join me? Let's get started. So I arrived at my new office. This time I'm at the 7th floor. It's nice, the view. I will let you see. And today I'm going to meet Zhaoli and his team. I will meet some PhD students, and I'm going to go through the presentation of. I will let you know what's coming next. So after finishing my meeting with Dr. Zhang, I had the opportunity to have another meeting with the PhD students. I had the pleasure to meet 5 PhD students working on exciting research projects in the field of thermal energy storage and phase change materials, all enrolled at Southwest Jiaotong University in Chengdu under Professor Jinping Yuan, Dr. Zhao Lidang, and Dr. Nan Zhang. Actually, the research covers a wide range of innovative applications. One of the students is investigating the heat transfer characteristics and practical application of thrombophores enhanced with phase change materials. Another project focuses on integrating solar collectors with phase change materials and mechanical ventilation systems to increase or accelerate the heat exchange and the transformation from a phase to another. A third PhD student is exploring the optimization of PCM containment through parametric geometric design, shaping materials in ways that can maximize efficiency and storage capacity. The research also extends to building facades, where one student is studying how phase change materials can be integrated to enhance thermal performance of building envelope and energy efficiency in architecture overall. And lastly, detailed work is being done on the thermal and physical characterization of various phase change materials. This is the 5th PhD student who is working on this essential research to understand how the PCMs perform under different conditions and in different climates. So for me, it was truly inspiring to see this group of 5 PhDs. They are all trying to push boundaries of science and advance it in the field of energy efficient design and renewable energy solutions here in Chengdu. And once we were done, we moved for a very nice collective dinner where we ended the day in the restaurant.
Real one. Salad, kiwi, jujube. Bye bye.
So when did you work here? Because this building is 5 years old, right? So when did he start here? Last year. 2 years ago.
Stop. Yeah.
Window of 8 to 13 micrometer.
So this is a coating.
Yeah, coating.
And they apply it.
Apply to the building outside,
Okay.
coating the building.
Interesting.
Yeah.
Interesting.
Like this picture. See, we're coating the material outside.
Yeah.
但是呢，传统的这种辐射制冷呢，它一旦沾了灰了以后，效果就没有了。
The cooling effect of the traditional radiative cooling will decrease if it has dust in the surface. I mean dust in the surface. Yeah.
So the dust influence of the dust will influence the reflection.
Yeah.
Okay.
所以呢，我们把借鉴这种荷叶效应原理，让它实现可以就是自清洁的一种功能。它 它主要做成一种疏水的表面，这样的话下雨的时候有一些雨滴，就可以把一些灰尘带走了。
We are inspired by a plant, but the plant has a super hydrophobic.
Lotus.
Yeah, lotus. Yeah, that plant, and the water will flow
And
from the
it's
surface.
repelling the
repelling
dirt.
themselves. Yeah, self-repelling.
Wow.
Yeah.
And they have developed a kind of material and they apply it also.
Yeah, they put this kind of character into the coating surface.
Very interesting.
这个呢，就是我们的一体化的板材，它实际上呢，传统的我们的保温层很容易就是着火，还有大面积这个脱落，还有一些构件锈蚀带来这种安全问题。
In the traditional thermal insulation coating on the outer surface of the building, they will have fire risk, and also they will easy to drop off. So they want to produce a new construction plate to prevent this.
So it's a kind of cladding.
Yeah.
And it's mechanically fixed on the outside. They fix it mechanically, or it's a cladding, or it's a coat.
我们这个是放在外面
It's a
还是里
paint.
面？
It's like this is like spray.
做成一体化的，为了我们开发这种新材料，把保温塞到里面，做成一体
It's a
化的
panel
板材。
system, and they fix it mechanically on the outside of the facade.
Inside.
Inside.
Yeah.
Inside.
Yeah. Inside.
Interesting.
最后的话，它就做成这种一体化的板材，而且呢，不用龙骨安装来代替我们一些外维护结构或者是耐隔墙。这样的话，避免了这种脱落，因为它本来的也是埃及防火的，也是自己强度很高的材料，
Yeah, it has high excellent of fire risk, and also it has strong power, strong ability. This material belongs to kind of prepared material. They can fix it very easy and put it together with the building.
And these are kind of
Patent.
patents.
Yeah, patents from Chinese.
And they are all Chinese patents, right? They test them.
都是国内的检测机构，第三方检测。
Patent and also
Certificates of
tax
performance.
report from Chinese national government or national center.
Institutes to recognize
Yeah,
the
to
work.
recognize the performance of the materials.
这个就是我们的空调设备，主要的解决两个问题，一个就是除霜，第二个就是噪音。
See, traditional air source heat pump, they will face
Cooling tower.
the cooling tower. No, yeah, the cooling tower. They will face the problem of
Frost.
Yeah, frost, and also they have a big noise.
True.
Yeah, so they want to solve the problem, so they develop the new air source heat pump.
And do they have this acoustic lab here?
Yeah.
Wow. Okay.
这两篇论文呢，其实就介绍的我们这个空气源热泵，它怎么样除霜的，包括它除霜过程中的实验相关内容。这两篇论文。
I can't help you with this.
Their research also has been published in these journals. If you are interested, you can check
And
more
they
details.
publish as what? They publish as
The second one.
China Southwest Architecture Design Research Institute. So they have a lot of publication on their name as a company.
Yeah.
Okay.
然后这个呢，就是我们这个热泵的做了它的噪声降噪的实验论文，就这个设备。
The sound test.
Building
of the
simulation.
air source heat pump.
Okay.
It's very interesting. They have a
对。
test lab in here.
And then when they test it technically, do they do economical study to check feasibility after?
Yeah.
Okay.
这个设备呢是我们的就是全空气空调机组。
Air handling
AHU.
unit. Air handling
AHU.
unit.
Yeah.
And what about it? They are trying to control or improve what? The filtration?
Yeah, filtration.
Filtration and
其实呢，它
Particles.
主要解决的
Particles
是
to quantify.
它主要解决的是我们传统的这种空调系统，因为一般是初效加中效过滤的，它到了疫情或者到了雾霾的时候，我的室内环境质量就难以保障。
It wants to solve the problem that traditional air conditioner system they cannot infiltrate many materials, through middle or through rust filtration.
And I have a question for him now. How they're very close to national research labs,
Yeah.
but here it's more they are serving their own company. So these topics
No,
come
not only for that company, they also sell for another company.
other company. So it is actually national service for companies in China.
Not
Construction.
for Chinese company.
Also international.
could supply technology or project to other companies.
Other companies. Okay.
像这款设备呢，其实我们主要是里面做了爬通，就是包括我们首先这个看得更清楚一些，我们可以出中效，过来了以后，只有在特别比如说疫情或者是雾霾的时候，我们再让它过高效，在其他天气呢，我就不让它过高效，这样的话，我的高效过滤就可以得到保护。延长使用寿命，而且呢，我平时的时候整个风机的阻力就降低很多，能耗就降低很多。
If the air conditioning is really bad, so the air will flow to another pathway with strict filtration.
They bypass.
Yeah, bypass. Yeah.
对，爬通。
Yeah.
Okay.
With a strict filtration to protect the air, enter the room will be clean and secured.
So they do a lot of control also, like sensors.
Yeah. In general, the air will from here to the building side directly, but in the worst air conditioning, we will go from the pathway.
Interesting.
我们可以去那边展厅有一些实物的这种模型，可能介绍的更清楚一些。当然，也可以从这边先看一下我们的这个实验室。
See, you will like this
是
one.
我们发表的一些相关学术论文。
The wall of publications.
Patent, Chinese patent, and
Yeah.
papers.
China patent。
Impressive.
这个是我们测牺牲的一个实验室，测牺牲的一个实验室。这边是我们做材料涂料的化学实验室。好了，
Yeah, sure. This chemical and materials lab. You want to go inside?
No.
This is for spectrum performance of the coating.
这边是我们的空气声的发声实验室，可以发一些标准声，标准多少分贝的实验室。对。
It's also for some test lab, but it's for standard voice, coming out.
For facades.
Yeah, for some source.
这个呢，主要测那个涂层的一些老化性能、耐老化性能、耐紫外性能的一些实验室。
Durability like ultra ultra. Yeah.
这个是测导热系数的实验室，半个小时就可以把那个材料的导热系数标定出来。
This is to test the thermal conductivity of materials.
Insulation.
Yeah, material.
我们中心现在博士还比较多，现在有20-30个博士了。
对，之前向波说。
是。
So you will find small product, practical product. You will like it. Small
installed
product.
outside.
Yeah.
这个建筑呢，也是所谓的近邻能耗建筑。
See, this is net barrel. Really? This one, this part.
对，
So it was designed from the beginning to be like that.
Yeah.
And when was this building constructed?
哪一年建立的我们这边？
建大概4、5年前吧，大概5年前左右。
5 years ago.
5 years ago.
对，我们搬过来是3年了。
So 2019.
Yeah.
这个呢是我们的西南苑的产业化科技公司，就是我们那边研发，这边来销售。
You know, this place belongs to from material developing material to product center in here.
Okay.
Yeah. Like the transfer center from research to product.
So the development.
Yeah.
So it's not only research, but research and development.
Belong to this part belongs to product.
Development.
Yeah.
我们涂了涂层的和没有涂层的，这个呢就可以看刚才说的那种这种荷叶，
Self-cleaning.
对，这个就是没有的，然后这个就是涂了的，涂了以后它就滚走了，没有它就不行。
This traditional coating.
对
This
对。
kind of. See,
涂到这些地方。
the coating can be used for this occurrence, like food storage outside, and also for communication state, and also for residential building outside.
And for oil silo and electric stations.
Yeah.
And hubs. To reduce the heat.
Yeah, reduce the heat and decrease the temperature.
Surface temperature to
Yeah.
reduce.
就是指导性的一些文件。
辐射有，现在的话已经编了那个 CECS 标准了，已经有，但是还没有上升到国家标准。
Very good.
But that fire is used for industrial.
看一会以后，它这个就是两种温度还是差异很明显。
对对。
这边也是这个玻璃上涂这个辐射制冷的，不涂辐射制冷的两个的对比，就刚开会也是也已经体现出差异了。
So the default assumption in China that it is hot.
Yeah.
And we want to keep the heat outside.
Yeah.
辐射制冷呢，就是在这些打芯的地方，其实都做过应用了，已经做过应用了。只是呢，有一些项目它没那么大，没那么大啊。
Has been applied in this seats with the red flag labels. You mean
它
factory?
有工厂。
They produce?
Yeah.
They their own factory.
They have their own factory and then they produce.
大概1个小时车程，
Ah,
1个小时车程，我们
about 1 hour.
对
1 hour drive from here.
Okay.
这个呢就是这表面两边也是分别对比，一部分涂了辐射制冷，一部分没有涂辐射制冷，然后看它里面的这个空气温度，已经差了5度左右了。
Same one.
Same.
Radiative.
But here,
But
this
this
is
is transparent.
This is-
Transparent radiative.
Yeah, this
对，这个
So you
呢
can see the
是
temperature.
透明的辐射制冷，那个呢是白色的。
this is the product.
yeah.
对对，
Transparent coating.
And they have also
我
roll.
们也做了这个膜，一部分是膜，一部分是涂层，不同的层。
Reducing electricity on the roof.
No, reducing electricity, better thermal insulation,
Better thermal insulation.
and good,
Durability.
I don't know how to say, connection
Connectivity.
connection with the building surface.
Okay.
Also, durability.
Durability.
Yeah, it can stand hot and cold area.
Impressive. Very good.
刚才说那个就是这座板层，在这里面填充保温层，它实际是靠这个我们的玄武岩纤维丝，然后做成出来的这个材料。
Glass is integrated in this.
In this, yeah, in this gap.
用这个纤维，还有加上树脂，通过拉挤，就成为这种产品了。这个呢，就是做好的实际的项目的一些效果。它做整个的外维护，质量轻，强度高。
It's lightweight.
Yeah, it's lightweight. Lightweight, and also has good thermal insulation.
Property.
这个呢，是我们做的微间发泡陶瓷。
So this is cladding marble, for example, and then behind it ceramic.
Yeah, ceramic, porous ceramic.
Porous ceramic.
它是一体化蒸出来的，它实际上是这边和这边都是化学成分，都是一体的，它不是粘接的。这样的话就掉不了了，脱落不了。
They make it as integrated part, and the two layers will not be separate from each other.
相当于它下面是发泡，然后
对，它是一面发泡，一面没发泡，最后就出来这种效果。
I got it. So that they don't need to do this mechanically after. It's only one.
Yeah, only one.
对对对。像这个材料呢，在我们自己的就是斜对面这个项目里面都已经应用了，就这个做出来就这种效果。
Their own office building, their own building use this kind of materials.
And what is this material? Is it artificial?
这个呢，这个主要是
人工制作的吗？这个是？
对陶瓷。
Also ceramic.
Ceramic also.
对对对，因为大理石和花岗岩它有辐射，所以用的装修材料里一般都不健康。但是我们做的陶瓷它是健康的，但它做出来了以后和大理石看起来没区别。
Wow. So it can have a very long service life.
First, for long service life.
Durability.
Second, will be safety.
Safety.
With no radiative effect inside the building.
来代替大理石、花岗岩。
Bio-based PCM. What is the material? What's the source of it?
This one?
Yeah.
This
He
one
said
is
bio-based.
fire-based?
He said bio-based. Or no bio-based. It's paraffin.
No, it's a kind of fatty acid.
Fatty acid.
Yeah, this one is fatty acid. Fitting materials. This one, I have no idea.
Okay.
This one is kind of PEG, organic fitting materials.
这个是我们也在做下面材料，但是我们做的是下面材料的 PCM 的应用。
This PCM.
PCM, yeah, this kind of PCM. Organic fitting material.
Organic.
Yeah, organic.
我们现在做这个相变材料呢，主要是解决相变材料的一个泄漏，因为传统相变材料固液相变过程它容易泄漏，我们现在把它做成那个微胶囊，用这种封装技术把它封装成微胶囊，这样肉眼条件下它是看起来是固体到固体的，固体到固体，它不会存在液体泄漏。
As you know, traditional fishing materials, they has the problem of liquid leakage. So they developed a foam stable fishing materials. It's a small one. It is called phase change encapsulate.
Okay.
Yeah, from we can see it. It transfer if the fishing materials change from solid to liquid, but from outside we can see it is also solid. Yeah.
Ask him, did they apply any phase change material to any buildings, or do they have a case study?
我们这边有就是实际的应用嘛，关于这个东西，相关材料的。This one.
What is this?
Another city is
This
called
is like housing or?
no solar heat thermal electric coal power system. This place is located to the northeast of the Centralized.
Okay.
Medium.
总共去年在西藏高原大概用了200多户吧，对，200多户。它这一个就是一户，一个院子就一户。
They're all zero energy.
Yeah, kind of zero energy.
Nearly zero energy.
Nearly zero energy. But they still need, as the the system provides, they still need a small battery unit to provide electricity.
做成这种这种地方出来，然后直接就卡接就行。
应该是有3个层，里面是电加热的，然后中间是麦材料，外面是绝热的。
对对。
然后这个做四面层。
对，这个就直接是做室内室面。
从外墙上看，它铺满之后就是这样一层外墙。
对，
就金属外墙嘛，就。然后那个墙上。
相当于这是不锈钢的，然后给它做。它这个
应该就是一个支撑的一个，不是一个支撑的一个。
And then they fix it on the roof or in the wall. On the wall. And what is the thickness of the PCM?
PCM
How thick? How thick?
2公分到3公分
，2公分
，20毫米到30毫米。
20毫米。
How much? 20 millimeter. Okay, 3 times. Okay.
This one belongs to the material that we see with solar collector. With photovoltaic system.
Okay. Okay.
这个实际上是在做改造项目，它已经有墙体了，这个是直接往
直接墙上一挂，
就不用
那它们也
附
做成
在一起。
一体的。
光伏的电会连到这里面，
对，
它里面有电热膜层，然后会把电线就相互之间连接，板跟板之间一连，然后就往墙上一挂。
Very good.
这个东西我见过。
它实际上是用我们的光伏发电，发电了以后用我们的电热膜加热，把我们的相面蓄热材料白天的时候蓄热，蓄下来以后夜间靠相面材料来进行供暖。
See, you can see this picture. PV system produce electricity in daytime and connected to a electric heater to provide heating. The heating can be stored in the phase change material system. After that, at night time, the stored thermal energy will release from the system to provide heating.
Okay.
主要是来代替我们的电池，因为
And
没
this
有
is
电池蓄能的话
water.
成本大。
Water.
对
So the water is here. It heats, and then they use it in the night.
对对 ，water and light。
Okay.
Photovoltaic system provide electricity and also provide thermal energy.
电池把电储起来。
对，我要储热要
Using
便宜
these
又安
materials,
全。
we do not need to provide electric power.
Completely.
Yeah,
And they
battery system.
They have also another building for that case study or something.
我们这边有就是具体的一个建筑用我们这个系统吗？还是？
Is it this one?
对
This one. So they did everything.
4个已经用的类似的有4个项目，这是其中一个
project applying this system.
对。
And did they publish about it something, or did they have any results? Are they optimistic? Find it good working? Not good?
就是哎，是的，我们这边的效果是，就是这个东西。
到了冬季了以后，举个例子，他一户人家大概200平米，到整个一个供暖季节，全年下来的耗电量只有200度左右，剩下的全由这个系统来供给。
They have calculated the practical performance. For example, in a 200 square meters building, in winter, the total used electricity is about 200 watt.
Wow. Okay. So it works very good.
Yeah. Kilowatt.
Kilowatt.
Yeah.
Yeah, it's very low.
Yeah.
哎，这就是那个的原理。对，用我们的光伏产生了电，然后我们的光能路由器，把我们的电一部分可以用于我们照明，一部分用于我们的电热水器，但是很大一部分，最大的一部分是用于我们的供暖蓄热，就用相变材料。为了整个系统呢，就是哪怕夜晚也能满足照明需求，所以呢，我们蓄了2000瓦时左右的蓄电。它这个蓄电主要是蓄电主要解决照明，大量的能量是相变材料蓄下来，来解决我们供暖。
相变材料都是在房子上面还是
墙板？
墙板，
对。
是外墙还是内墙？
内墙。在里面放的，但是实际上是对外墙做了保温，对，保温相变材料，电热四面做成一体化板，因为它原来没保温，我们素面就把保温也给它做了。
就正好一体化，又是保温又是加热的蓄热系统。
对。
It belongs to this system.
To this system. Yeah. 这个
结构方面的。
保温隔声一体板。我们这底下这一层是隔声垫，然后中间是保温层，上面是地暖管。
And can this resist mechanical
Sure.
force on it? So walking on it?
Try it.
这个这一层做了个均热板，这样的话我把线热源变成面热源，然后干湿铺装了以后，我的热响应速度会得到很大的提高。
It belongs to the floor heating system. See water pump on this side, and also the surface is kind of thermal insulation material.
And then here you can put mortar and ceramic after. Normal.
It's really hard to culture.
And then the thermal losses are very low because this is insulation.
Sure.
So the heat loss is very low.
Yeah.
But in China, I want to ask you a question. In China, do you install a lot of floor heating systems like that in China? In residential or in office? This type of systems in residential building?
副总，就是我们这个辐射制冷的这个系统是用的多吗？辐射供暖的这个系统用的多吗？多。是用在我们这个商业还是那个就是
住宅。
It has a lot of floor heating systems that used in residential building.
Residential.
Yeah.
对。
And this is for heating.
Yeah, for heating.
Okay. But no cooling.
No cooling. 我们这个不制冷吧？
不制冷。
对。
因为制冷有个问题就是地板辐射制冷，它温度舒适性好，只是它温度不能太低，低了以后结露，温度不能太低，这就导致它的这个供冷的功率有限，就是供冷功率偏低，所以还得有专门的补充。对，供暖的时候我峰值负荷也就40瓦左右的这种负荷指标，那供冷的时候100多瓦，所以用辐射制冷呢，它还必须有其他的能源补充。
Only floor heating.
Yeah. If it used for cooling, it has a problem. It's
Humidity.
Humidity.
Condensation.
And yeah.
对，它的这个供冷的功率。
And also the cooling power cannot be too high to prevent the concentration.
Yeah.
Yeah.
And what is the latest research or the biggest problem today they are working on? They are working. Yeah.
就是我们这边是吧？就是做现在这些产品还有这些设备东西，就是现在主要做的东西，或者说主要的一些就是现在的一些方向，就是所谓的啥？Research.
Yeah. Is it Do they have HVAC, more like heating, or is it the ventilation, or is it cooling? What is the biggest problem they still try to
就是我
solve?
们研究现阶段这些产品啊研发面临的一些可能的一些问题啊什么之类的，是哪个方面的？
技术方面嘛，
对，技术方面。
技术方面的问题，其实目前面临的主要是怎么样快速推广。技术方面已经经过了很好的验证，无论是实验室验证还是试点工程验证，目前没有问题。真正问题还是怎么样的快速的市场推广。
There is not too much technical problems in their product or their research. They want to promote their product to the market.
They want to penetration and roll it out and open the market for the product. Interesting. I very appreciate it. Very good work.
这个是它的整个的一个结构体系。
See, there is a floor heating system. Structure layers, connection layers.
So they do acoustic, comfort, ventilation, finishing, radiative cooling. They do fire? No fire.
No fire.
No fire.
No fire. 我们这边防火应该
B1级。哦，防火等级 B1级。
B1 layer, Chinese standard B1 layer.
B1 layer.
For construction materials.
And do they do construction underground also? Or is only mainly buildings?
I think mainly buildings.
Mainly buildings. Thank you.
代替天然石材。这个就是我们刚才看的设备，对，有空气源的设备。对，这个是我们刚才看到的
Air handling
空调机制，对。
And then they apply it already in a lot of buildings.
对，在这个呢，在这两个项目里面应用。
And also their own building.
这个是我们的对欧办公区，然后用了那个设备来进行供热，用了6台。
The second working on that company, they use the air conditioning pump
来代替天然气锅炉。
to instead of the natural gas boiler.
Natural gas boiler.
这个是做好的一个项目，黄原机场也适用的这种设备。
The system for the Guangyan Airport.
这个还有在那个三星堆博物馆用的这个三星堆博物馆这个设备，乐山机场也用的是这个设备。
Really nice view.
他们最近把实验做完了。这个就是测这个透明维护结构，这个可以不断的换，测它的整个的热构性能。我们首先呢，通过那边的气象站，把室外的温度、湿度、太阳频谱、风速等全部测出来。对。
And humidity, temperature, like that.
And these are test chambers.
Yeah.
And what are these tubes for?
Tubes?
The storage.
雨量。
For rain.
Rain.
Yeah.
And what they are measuring here? What is the test about?
With transparent thermal performance of the transparent materials.
Glazing.
Yeah,
surface
glazing, yeah,
with
surface.
low emissivity coating or something. Okay.
这个最近实验刚做完，实际是里面有环境监测系统，外面有气象系统，然 后我们测它的一些各种热流参数，来看整个这个玻璃的一个热工性能。
We want to test about the thermal performance of the glass.
And the orientation, this is south.
这边是朝南的吗？
这边是朝南，它是可以转的，对，它是可以，
啊
我们也可以，
This device
对
moved.
可以转的，看不同角度它整个的一个情况。
Okay. And this is mainly for thermal performance, not for visual performance. Right?
For thermal performance. For visual performance, we need to turn around.
对对。
And there is a computer inside the unit?
Connect to the thermocouple.
这个呢，就是两个做一些这个同时的对照。
This is the same device but used for reference.
This is the reference.
We
This is the base case, and this is alternative.
yeah. This is the best case. We compare the thermal performance of the two materials.
Okay. And they have insulation.
No insulation.
现在也做完实验了。
这个应该是封闭的吧？没有通风什么之类的。
封闭的。
No insulation.
No insulation.
对
Just a closed
但是我们要靠温度，我这个空调来控制它的这个温度。
对。Air conditioner to control.
So this is a full test cell.
Yeah.
Base case, cooling load,
Yeah.
base, and then they improving the glazing or adding more reflectivity or
Yeah, you're right.
lower emissivity.
Yeah.
So they do also glazing. They have experts in glass.
Yeah.
Do they do visible? Yeah, we said thermal glass.
Visible,
Yeah.
invisible performance, not too much. I
Not
think.
more thermal.
就是我们这边就是透明的一个玻璃光线测的应该不是特别多吧？就是光学性的。有一点
都测了，
哦，
也测了。
They also measure the.
But who are
Yeah,
the researchers? They come from which university? Also from South.
我们呢可能也同时
No.
会在一些标准的实验室，然后把它的这个玻璃的频谱特性也会标定。
哦，They also will test the spectrum performance of the glass.
And this is double glass. Triple.
双层的吗
这个应该是双层的。
？Yes.
双层。
Yeah,
对
double glass.
对。
Double layer glass.
And any solar protection or external shading, because in Europe, I know this is not like in China, but in Europe there is a lot of external shading, automation. Is there in China? Is it common to put external shading?
就是室内遮阳，
这样。
室内的就是室内里面的遮阳。
这里面没设遮阳，
No.
没设遮阳。对，因为室内遮阳，毕竟能量已经进去了。 可能室内遮阳了，只有那种特别反射特别好的，你照进去的这个可见光，一照上去直接反射，还是可见光它才能出得来。一旦变成吸收率比较高的以后，它热量是长波辐射是出不来了。
它可能是那样的，就是因为当我在比利时也待过2年，
啊
就是它比利时那个地方，因为它纬度比较高，
啊
比较冷，
对
所以它希望热量进去，
啊！
就跟
它希望热量进去。
对，就跟我们可能这个地方
我
不太一样
们这边呢，可能最主要的，因为到冬天的时候太阳又不好，也进不去多少。
对
然后夏天的时候持续的时间很长，热量又很大，所以呢，主要解决的是夏天的问题。然后我们在高原了，就不是这样了。在高原的时候，我们希望的是太阳能照进来，但是呢，照进来的时候呢，传统的这种玻璃呢，如果你用一层玻璃，80%几可以照进来，但是呢，这个玻璃的传热系数又很大，热量晚上又对流又走了，所以我们做了2层。白天的时候，我把里面的一层中空玻璃打开，外面是一层单层玻璃，太阳大量的照进来。晚上我把它一关，然后传热系数又很小，然后热量又出不去，做了这个。
那就是从结构上给你改善。
对。这个可以把它的直射、散射都测出来。
Complete station. Complete station. Okay. Thank you.
这些都是配合的一块做实验，它不同的
What is the same?
历练上，它都会在哪效果。
This is also used for test the thermal performance of the glass. with a different incline angle. You see?
Okay.
Yeah.
So they have a glass specialization.
Yeah.
So it's HVAC, ventilation, material finishing surface, and also glass.
Yeah.
Very good.
Glass, we focus on the thermal performance of glass, especially as for the spectrum characteristics.
Spectrum.
We will use another lab to test it.
And this is coating, material finishing.
这个是我们的这个复合材料，这个是用聚氨酯，然后玻璃纤维复合拉挤的材料。
For facades.
对，这个也是，这个是造了涂层。
Plastic.
对
Polymer. No
对
aluminium. Not aluminium. It's not aluminium.
对，
对。
它是对，它纤维复合材料用的聚氨酯。聚氨酯是怎么说？
Polycarbonate.
聚氨酯，
PU.
Polyurethane.
Yeah.
Polyurethane.
聚氨酯。
Lightweight and strong.
Yeah. Like
And weather resistant.
yeah. They are maybe
聚氨酯和树脂和玻璃纤维。
PU. 树脂咋说？resin 是吧
Resins.
resin
Okay.
resin and glass fiber.
Glass fiber.
对，玻璃纤维。
And this is for water repellent feature, right?
这个是看它的一些涂层，各种各样的涂层的耐候性的。
The
对，耐候性的。
For the resisting of the coating.
ceramics.
这个上面是涂的涂料。
It's like electricity cable.
对。
Okay. So the building has a certificate of green building design label, and this is from the Chinese Green Building Council, and then it has a nearly zero energy building certification from CABI, and it has a certificate of carbon neutrality, and it has a LEED gold certification. So today I'm going to take you to the campus, to the university. I'd like to buy some material for my study of Chinese. So stay tuned and let's go to the campus. I know the... Yes. Yeah, so I'm with Zhao Li. I'm going to visit a bookstore because I need to get the study material for learning Chinese, and I will take you with me. Let's go. So I'll take this and take this.
This.
This is also good.
Yeah. Pinyin and Chinese.
Okay.
Chinese.
So if I would choose this or this?
This.
This, okay. And you said one more from there?
Yeah.
10,000 words? That's too much.
Yeah, it's
And what are these? Oh, this is nice.
you can buy one. Sure. P and one.
Then there's level 2. Hi guys, I'm going to meet one of my early university colleagues. His name is Farouk, and I will have a meeting with him. He came especially from Nanjing. So I'm looking forward to talk to him, and stay tuned.
Assalamu
How are you?
Alhamdulillah.
Everything good? Have a seat.
Okay, thank you.
Join.
Bismillah.
So, I'm Farouk.
Yeah.
Welcome to my channel. I'm very happy to have you here in meeting you in Chengdu. You came with an airplane from Nanjing.
From Nanjing, fly from Nanjing, yes.
How many hours?
Around 2 hours, I
2
guess.
hours.
Yeah.
Okay.
2
Long
hours and
trip.
something. Not that long, alhamdulillah.
Good. So how long have you been here in China?
Oh, I guess now around 11 years or something.
11 years.
Yeah.
Cool. Actually, Amr, we were in the same university. We studied at the same Faculty of Fine Arts in Cairo. And back then, we were very close. I mean, the same, I think, how many years is the difference? I graduated 2002.
Yeah.
And you graduated?
2007.
2007.
Around
so
5 years.
I think we had a kind of connection
True.
indirectly.
Yes.
And I got to hear from Amr that he was attending one of my workshops in Cairo, but since then he went to the Politecnico di Milano. I will let him introduce himself. He has a very interesting career path. But the most interesting thing is that he's really now based in China. And this is very rare. So there's a lot of points to discuss with him, and I'm looking forward to collaborate. Maybe also he's looking forward to continue doing research and connecting to Belgium and Liège University. So maybe I will proceed with the first question. Amr, what brought you to China actually?
At the very beginning, it was I come here for work, and then my family also here. So it was a double direction to here. Academia here also in China, it was on the rise, and so many friends who actually moved during that time, 2012, they were starting to say that China on the rise, let's go there, maybe there's some opportunities and could be inshallah a good direction to go for.
Nice.
Where I was working in one of the companies here, it's the head of the company and the architecture department, he's a professor in university. And then he said, why don't you come just give us a hand there. There's also a graduation project. Let's come be part of the jury. I accepted his offer and went there. And then this has become like the, let's say, the footsteps getting into academia. And then step by step, I found an opportunity to work as a visiting scholar at the University of Southeast University, Dunan Tashir. And this is where I started to teach the bachelor students in architecture design studio, and it was around, so I worked there for around 3 years, considered 3 years. This is how
Good, nice experience.
Yeah, it was the beginning.
Most probably you will stay for a long time to work.
Yeah.
And my question to you is, like, we are today in 2024,
Yeah.
and China is changing, the world is changing. What would you advise future
students worldwide who are studying architecture, urbanism, landscape, while they are studying in their home countries or home institutions, what would you advise them to do in regard to China? Would you advise them to visit China, to do an internship? What's your opinion about it?
I think China is absolutely different landscape, different people, different culture, and it must be explored. I mean, most of the time when we are in the Middle East or even in Europe, even United States, it's absolutely somehow detached and have, like, let's say, distance from China, specific China and Asia in general. Students must be explored to so many different perspectives, different thoughts, different landscape, different way of thinking. And the culture is one of the base changing and big factors in architecture. So with being exposed to different culture and different people, different way of like even learning and unlearning things.
So you advise to do something in China during the study, let's say, visit during a summer training or a summer school, do an internship, something like that.
Yeah, you must come here at the very beginning just as exploration, and then you will understand exactly what's happening, why you should move and then come to here to China.
And how to do that? I mean, China is big and people get lost. So do you have any advice where to start? Should they just follow the ranking? I heard you talking earlier today with me about the importance of the ranking of your university. How do you think?
It depends, because actually in universities in China it has local rankings and it has international rankings, so it's important to monitor both the international rankings and the local rankings, because both of them play a big role to understand how well will you be also, let's say, facilitated, and how the things around you can, like, let's say, welcome or to be recognized also. Because in China there is also, like in other countries, they have their own, let's say, their own platform of how they perceive and have people around. So the big city is always full of communities, international communities, people from everywhere. You can find even like facilities, food, especially food.
So maybe the advice is big city,
better,
a well-known university that is friendly for international students. Maybe if there's any exchange program with the home institution, this would be a good idea.
Must.
Okay.
All these things are a very good start.
Yeah.
This is actually how you can familiarize yourself with the environment and the things, and then you can tell by yourself when you come here.
And then go specialize and explore and contact people. Okay, I think that's a very useful tip and advice. I will continue working with Amr and having our business meeting. So stay tuned, and I'm very glad to have Amr with me on the channel. And maybe we'll meet him next time or somewhere else. I hope to meet him maybe in Nanjing. I was never there, so I'm looking forward. Maybe you will find new videos popping up next year where I will be hosted by Amr. But it was really nice to meet you. I'm so happy. I'm so excited. Unbelievable, you find one of your university graduates in China. So I appreciate you came, and I'm looking forward to continue collaboration.
Thank you very much, and you are welcome also to come visit us in Nanjing later on.
Sure. I will leave his contacts and everything in the YouTube down. So don't hesitate also to contact him. He's also available on LinkedIn. He's a very, very smart guy, a lot of experience. He knows a lot of things about China. He worked also in Italy. And definitely, if you want to have an exemplary professional, Amr could be a very good person to follow. So see you later, and we'll continue. And just like that, another incredible journey in Chengdu comes to its end. I enjoyed my stay at Southwest Jiaotong University. I had insightful meetings. I enjoyed the amazing, inspiring discussions with the PhD students. My catch-up with Amr Farouk for sure was very unexpected. And definitely, I'm glad to have been visiting the China construction company. I learned a lot from this visit, and it gave me an idea about Chinese construction market, and even hunting some Chinese learning material. This is the first time that I start to be able to read a bit some Chinese and understand some conversations. So I'm looking forward to come back. China has once again amazed me with the progress, with the generosity, with the endless opportunities to learn and to grow. It's easy to say goodbye because I have a project and I'm coming back next year. And I have a heart full of gratitude and a head full of ideas now. So until next time in China, thank you for everything and 再见.